Question 29 says to find an equation of the line described below. Write the equation in slope-intercept form, meaning get the equation with y solved, meaning y is all by itself, when possible. All right, so this is very similar to question 28 that we just looked at. And again, we have been given two characteristics of a line and asked to come up with the equation of that line. In this case, we've been given the point 7, 3 and 3, 7. Now, you will recall in class that you really need two things in order to be able to write the equation of a line. You need, first and foremost, a slope, and you also need a point. These are the two pieces of information that we need in order to be able to write the equation of a line. Well, in the case of number 28, have we been given these two pieces of information? No, it doesn't look like it. The only two pieces of information we've been given are 2 points. So we've got ourselves a point. In fact, we have two of them, but we don't have a slope. We're missing the slope. And what that tells you is that you're going to have to first find the slope of the line between these 2 points, and then once you have the slope, you can use that slope with either of the 2 points that were given, plug the slope and the point that you choose into point slope form, and work it out. So let's go ahead and do just that. So first and foremost, let's find the slope between these two lines. And again, from previous, earlier in the practice test, we know that when we've been given 2 points, the slope between those points can be found by the equation, by the formula. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So if we're dealing with the points 7, 3, and 3, 7, as we did previously in the practice test, let's go ahead and label our points. So this will be x sub 1, this will be x sub 2, and of course that means this 3 here will be y sub 1, this 7 will be y sub 2. So now we've got the formula we're using to find the slope. We've got our 2 points. They're labeled. Let's plug and chug for the formula. So m is equal to y sub 2. Well, based on how we labeled our points, y sub 2 is 7. So 7 minus y sub 1. And what is y sub 1? Well, based on how we labeled our points, y sub 1 is positive 3. And that is all over x sub 2, which we've labeled as 3, minus x sub 1, and look at it, I made a little error here, didn't even catch it. The denominator, x sub 2 minus x sub 1 is the formula. So we have x sub 2, which again is 3, minus x sub 1, which we've labeled as 7. All right, so now that we've got everything plugged in, we can go ahead and clean this up. So m slope is equal to, and we'll distribute here, we will distribute here. So upstairs we have 7 minus 3 over downstairs 3 minus 7. And simplifying our numerator and denominator for the final time, well, 7 minus 3 gives us a positive 4. Downstairs in our denominator, 3 minus 7 gives us negative 4. And of course, we can reduce positive 4 over negative 4. Positive divided by negative is always negative, and 4 divided by 4 is 1. So our slope between these 2 points, the slope of the line that we are coming up with, the equation is negative 1. So let's go ahead and off to the side here, now that we've found the slope, we'll say that the slope is negative 1. And what point should we use with point slope formula? Well, again, it does not matter which point you choose to use. You are going to get the same equation. Now, as I erase this, I will say that when choosing a point, sometimes it's helpful to choose the point if one of them has a 0 in it. So if one of these two ordered pairs had a 0, I would choose that one because that makes things nice and easy to work with. Or if you have the choice between using points with negative signs versus points with both positive coordinates, I would certainly choose the point that had positives over negatives because, again, it's less likely that you will make a little an error with a negative sign. So it does not matter which we choose here. How about we go ahead and use the first point? We'll use 7, 3. And again, let's get into the habit of labeling these points. So this will be x sub 1, and of course that means this will be y sub 1. And now that we've got ourselves a point, we've got ourselves a slope, we can go ahead and use the point slope form, which is y minus y sub 1 is equal to m times the quantity x minus x sub 1. So let's start plugging and chugging and see what happens. So we have y minus, and what's y sub 1 based on the point we chose? That would be 3 is equal to m, and based on the algebra we performed, we know that m worked out to be -1, so we'll substitute that value in, times the quantity x minus x sub 1. And what is x sub 1 based on the point we chose? Well, that's going to be 7. All right, so let's see what we've got here when we clean up this equation. Here on the left, we're going to distribute. So when we distribute the minus sign, we end up with y minus 3 is equal to -1 on the outside. And first things first, I'm going to clean up what's inside this set of parentheses. So when we distribute that minus sign, we end up with x minus 7. And we're almost there now. We can continue to clean up the right-hand side by getting rid of the parentheses through distribution. So let's distribute. So on the left, we still have y minus 3 is equal to, now that we distribute, -1 times x is simply -x. -1 times -7 gives us a +7. And again, you have to always go back and look what form do they want us to write our final answer in. Write the equation in slope-intercept form, meaning solved for y. We want y equals mx plus b. Well, we're almost there. The only thing we need to do to isolate that variable y is to simply add the constant 3 to both sides. And simply by doing that, -3 plus 3 is now gone. So the only thing remaining on the left is that y equals, and now -x, and 7 plus 3, of course, is a +10. So here is our equation in slope-intercept form. Let's go ahead and type our final answer. So we have y equals -x plus 10. And there we have number 29.